Hi everyone, I'm Rishita back with my third YouTube video. So today's topic is visualization of basic propositional logic in Python. So first of all, what is propositional logic? Propositional logic is concerned with a statement to which the truth values, that is, the true and false, can be assigned. The purpose is to analyze this statement either individually or in a composite manner. So first, I have already written a file that is from logic import that load our operations in logic. So now I'm going to set up operational propositional variables like operations as function variable which take a list of string as the name of for those variable. Now let's have a look. So pqr is my string. Now I want to check what is p. So for p, let's check this. What is p? So P is a proposition. Now it is Q. So Q is also a proposition now for R. So R is also a proposition. Now I'm building a propositional formula that is formula 1 P, so P or Q and not P, yeah, implies Q. So this is my formula. Now I want it in position, and let's see formula 1. So yeah, you can see this, the proposition form. This is my formula. Now I want to print the truth table for formula 1. So let's for formula 1. Now so you can see this is the truth table for formula 1. Now I want to find the tautology for formula 1. So formula 1 dot is underscore tautology. Let's see what happens. So it gives me two. So tautology is true. Now I want to make another formulas like formula 2. Formula 2 equals to the P and Q implies R, and formula building another formula that is formula 3, 3 that is the P implies the Q implies R. Let's see. Now I want to print the truth table for these two. So let's print truth table for 2. So this is the truth table for formula 2. I also want to find the tautology for formula 2. So for formula 2, that is let's see, false. This is the formula 2 for tautology is false. Now I want to print a truth table for formula 3. Let's see. So you can see this is the truth table for formula 3. Now for tautology for formula 3 is, let's see, false. The tautology for formula 3 is false. Now I want to find contingency and contingency. The formula 2 is true. Now for 3, let's see what happens. Contingency, so it's true. Now I want to find are those formulas are equivalent or not. So formula 2 is equals to formula 3. Let's see. Yeah, it's true. Both are equivalent. Now I want to make another truth tables. Let's see. U equals to P and Q. P equals to capital P or Q. W equals to P implies Q. X equals to not P. Y equals to implies. So I want to make a truth table for those. So you got you got you, you dot print underscore truth table. Let's see the truth table for you. So you can see this. This is the truth table for you. Now I want to make truth table for B. Let's see. So this is the truth table for B. That is P or Q. Now I want to make a truth table for P implies Q. So this is the truth table for P implies Q. Now I want to make a truth table for not P. So let's see. So this is the truth table for not P. It's simplest. Uh, for table for another one, P plus Q. So this is the tutorial for complex. So thank you for watching my video.